Welcome, students, to another video lecture with Mr. Knapp. We're closing out our geometry lesson of shapes and 3D figures and 2D figures with finding the surface area of three-dimensional figures. So go ahead and pause here and copy down what you see. Okay, welcome back. So this lesson is going to cover 12.8 through 12.10 in our textbook, and all three of those lessons are focused on surface area of a variety of three-dimensional figures. So our essential question today is, how do we find the surface area of 3D figures? And if you didn't know, surface area is the amount of area around a 3D figure. And the way I kind of think about this is it's the wrapping paper of a present. So surface area to me is like the wrapping paper around a present. And this gets used a lot in like building wrapping paper or building boxes. You have to know how much area is around something in order to buy some materials sometimes. So we're going to go through our steps here on the right page. I'm going to jump another slide so I have some room to do this. And again, this is not finding the volume, so we're not finding volume at all. We don't want to know how much fills up the box. We want to know how much would go around the box. So again, as if we were wrapping this box in paper. So step one is identify the shapes around the figure and how many of them there are for each. So what this is really asking for shapes around the figure is, what are the faces of the 3D figure? So we're talking about the faces. How many faces are on this shape? Yeah, you're right. There's 6 faces here. So we have to have an area for 6 different sides. But I can't remember which sides are which on this, so it turns out an easier way to do this is to imagine it being unfolded. So I'm going to start with the base of the rectangle. I'm going to actually draw it into a composite figure like we learned in 12.3. And the base of our rectangular prism we see up there is, it kind of looks like this is 4 and this is 10. And then if we rip that box down a little, we're going to have another rectangle here. And this will be 3 inches. And if we pull that off the top on the other side, that would be 4 inches. And this will be 3 inches as well. Oh, and then we got to get the lateral sides here. We have this unfolded here. That would be a 10 by 3 inches here. And then we have another one there. And lastly, one more. This one will actually be 4. So that was me attempting to unfold the prism, the rectangular prism there, and show all 6 faces. And you can kind of know you unfolded it correctly because there should be 6 faces, and there should be, on rectangular prisms, there'll be identical rectangles, just as if this was the left, the right, the top, and the bottom. So this is the bottom, this is the top. These are my 2 sides. Trying to help color code with the unfolding here. And again, you can use either strategy here. You can draw it unfolded, or you can imagine what these shapes actually are. I've had trouble with students imagining what shapes are here, and I have had better results when students draw out the unfolded prism. So please try to draw it out. So now that we unfolded it out, how many different rectangles are there? Yeah, you're right. There are only 3 different rectangles. The top and the bottom are the same. The left and the right are the same. And the front and the back are the same. So we actually only have to do math currently for 3 rectangles. And I'm going to keep my color coding. But since you probably don't have color coding on your paper, you're going to want to say rectangle 1. And I'm going to stick to my rectangle 1 as the red colored one. And don't forget, check your notes on 12.3. What's the formula for the area of a rectangle? Yeah, you're right. It's base times height. So to find the area of that rectangle, its base is 4, and its height was 10 for that rectangle. And its area equals 40 inches squared. And again, since we're doing surface area, the units are only going to be to the second power. Then we have rectangle 2. I'm going to do green as my second one. And the area of the rectangle formula hasn't changed. Again, please be organized when we do this. What's the base and the height of the green rectangle? Yeah, you're right. It's 3 and 10. That gets us an area of 30 inches squared. Then we have our third rectangle, the smaller one. And the area of the rectangle formula hasn't changed, still base times height. Notice, even I write it every time. What are the base and the height of that last rectangle? You're right, it's 3 and 4. You may have noticed the pattern. We need to make sure that the 4 and the 10 are multiplied together, the 3 and the 10 are multiplied together, as well as the 3 and the 4. We've literally done every combination of these dimensions. So we got 12 inches squared. Okay. So now to find the surface area, which I'm going to abbreviate SA, we have to add up each of the shapes. So we have to add up each of the shapes. So we have rectangle 1, and I'm going to use R1 plus rectangle 2 plus rectangle 3. Oh wait, that's only 3 faces. I thought we had 6 faces. What do we need to do here to get all 6 faces? Yeah, we can just actually multiply each of these by 2, or the whole thing by the number 2. So notice I set up an equation before I solved the problem. So now we're just going to substitute in here. The surface area equals 2 times rectangle 1, which was 40, plus, hear me dropping pens over here, plus 30 of rectangle 2, plus 12 of rectangle 3. Follow the order of operations here. And the surface area of that rectangular prism is 164 inches squared. So again, the challenging part of these lessons is going to be learning how to unfold the shape. And it does get a little bit harder once we do cylinders and cones. But for the rectangular prisms and so forth, it's really the easiest is to undraw that shape. So let's jump ahead to example 1. Go ahead and pause here and copy down what you see. Okay, welcome back. So we have this, again, it's going to be important. Usually the directions are helping us. Find the surface R, that should be area, of the square pyramid. What's the basis shaped then if they called it a square pyramid? Yeah, it's a square. So I'm going to keep on following that pattern where I'm going to unfold the shape before I try and do my math. So we have a square. And I'm going to always label my numbers once I know them. And I know the base of the square is 12 and the height of the square is 12. And then since it's a square pyramid, what shape are these faces that are coming off each of the sides of the square? Yeah, you're right. They're all triangles. So this is what the shape looks like unfolded. And then it's just like 12.3 where we're doing area of composite figures. And it's going to be 13.4 yards there. Since it's a square pyramid, are any of these triangles different from each other? No, you're right. None of them are different. So I'm going to get a little bit of paper here, make some room. So we only have 2 actual shapes, square and triangle. And what is the area formula for a square? Remember, reference your note. Go check. Yeah, the area of a square is base times height. And while we're at it and looking things up, what's the area of the triangle? Yeah, you're right. It's 1/2 base times height. Okay, so let's do the squares math first. Our base is 12, and our height is 12. So the area of the square equals 144 yards squared. Area of our triangle is going to be 1/2. What's that base of that triangle's length? Yeah, once we unfolded it, it was a little easier to see that the base length that was 12, and the height length was that 13.4. Okay, then we're going to find the area of the triangle. 6 times 13.4. I'm going to have to do that math on the side for you. Okay, the area of the triangle is 140.4 yards squared. Let's hope I didn't make any mistakes in my math today. I did that a little quick in my head. Okay, now we have each area. So going back to our note, what do we do now? That's right. We solved for each area in step 2 here. And now we're actually having to add each shape's area together. Okay, well, oh, that's too far ahead. There we go. So surface area here. We have how many squares are showing up in the problem? One of them. So we have our area of the square. And then we have to add to it the area of the triangle. But how many identical triangles are there? Yeah, you're right, there's 4 of them. So we should put a coefficient in front. We should multiply this area of the triangle by 4. So now the surface area, we're just going to substitute in. We have the surface area of the square is 144 plus we have our 4 times the area of the triangle, 140.4. And now we're just going to follow the order of operations. So our surface area, we're not going to do anything with the 144 yet. We have to multiply 140.4 by 4 first. That's going to get us 561.6. Yeah, I was doing that math in my head. Someone double check that on a calculator for me. Did I do it right? Yeah, I did. Oh, thank goodness. Okay. 561.6. And then we still got to add those together to get our final surface area answer. And that's going to get us up to 705.6. And what is our unit here? Since we're doing surface area, it's going to be yards to the second power. That's the answer. Again, so we're following this pattern for everything. We're trying to unwrap it into its smaller shapes, find the area of each smaller shape, and then add them back together. So now we're going on to our cylinder problem. The cylinder is a little more challenging for students because we sometimes have trouble finding one of these sides using the numbers they provided us in the problem. So let's go ahead and unwrap these things. What shape do we get from unwrapping the can? So if we unwrap the can, we know we're going to have a circle on the top and a circle on the bottom. But what shape do we get from the height of that can when it's unwrapped? Yeah, it's a rectangle. It's a rectangle that kind of looks like that. That's how we unwrap a cylinder. Okay, so they gave us this radius is 6, and they told us this can is 12 high, but how do I find the length of this rectangle? How do I find that length? Well, this rectangle wraps around the can, and the base of this can is what shape? The base of this can is a circle. And what do we call going around a circle? Yeah, it's the circumference. So the length right here of our rectangle is really just going to be the circumference of the circle. Okay, so we have two shapes here. We've got a rectangle and we have a circle. Well, the area of a rectangle is pretty simple. It's just base times height. But our base, or our length of this rectangle, is actually the circumference of the circle. So we're going to have to do a little bit of math on the side here. How do I find the circumference of a circle? Yeah, if you're having trouble on this, go back to your 12.1, 12.2 note. Double check. What's that circumference formula? Yeah, for this problem, the base, which is the length of our rectangle here, we're going to have to use that circumference formula, which is 2 pi r, or you may have actually read it as the way it's written, which is pi times diameter. So those are the same formula I just substituted in there. So let's actually find the base of this rectangle. What is the diameter of our circle? Yeah, our diameter is 12, so it's going to be pi times 12. I'm going to need your help punching that in a calculator. And we're actually going to continue this part of the note at home or in class. So this was actually the hard part. I wanted to get at least through the fact that to find the length of this rectangle for the surface area problems of a cylinder, we will have to do a little bit extra math because the length of the rectangle is actually the circle's circumference. So we have one more problem. Leave some space after this cylinder problem. We're still going to have to finish the math there, but I want you to get the cone drawn already. And then we're going to finish this lesson now because I don't want our video lecture to go too long. So make sure you copy down the surface area of the cone problem. We'll do that one in class. We're going to finish the cylinder problems math in class, so we need room for that as well. And if you have any questions, remember, write them in the question columns, ask them in class. I love to have them here. I hope this wasn't too long, and I apologize for the extended part. I'll see you soon.